If we have a quadratic function f of x equals ax squared plus bx plus c, then our vertical stretch factor is a, consistent with what we've seen. Our horizontal shift is negative b over 2a, and our vertex lies on the axis of symmetry, which is at negative b over 2a. So we're saying this function has zeros then by the quadratic formula at x equals negative b over 2a, negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can write this as negative b over 2a plus the square root of b squared minus 4ac over 2a. Negative b over 2a is the coordinate of the x-coordinate of the vertex. It's also then the x-coordinate of the axis of symmetry, because the axis of symmetry goes through the vertex. This square root of b squared minus 4ac over 2a is how far to the right or left the zeros of the function occur relative to the axis of symmetry. In other words, how far to the right or left of the axis of symmetry we get the zeros. Okay. Axis of symmetry is at x equals negative b over 2a, so 1 0 is this square root of b squared minus 4ac over 2a, this thing, to the right of the axis of symmetry. The other is that far to the left of the axis of symmetry. So we have a picture. Here's our complete basic squaring function. Here's our f of x function. It's been vertically stretched by some factor, which is the coefficient of x squared, that's a. It's got axis of symmetry at x equals negative b over 2a. Vertex lies on that axis of symmetry. And the zeros lie square root of b squared minus 4ac over 2a to the right of the axis of symmetry. That's at x equals negative b over 2a, the axis of symmetry, plus this shift, and at x equals negative b over 2a minus square root of b squared minus 4ac over 2a. If you want to find the horizontal shift to get this graph from this one, the horizontal shift is just negative b over 2a, because you're shifting from 0 to negative b over 2a. What's the vertical stretch? Well, I labeled it over there. Here's why. You have a times x minus h squared plus k expands to give you ax squared minus 2axh plus h squared plus k. You can do that yourself. The a here is the coefficient of x squared. Okay, so you have your ax squared, same as what you have here. Your b would be the 2ah times x, and your c would be h squared plus k. Your vertical stretch factor is a coefficient of x squared, and in any case, so the vertical stretch factor is a. To get the coordinates of the vertex, you know that the x-coordinate is negative b over 2a. You just plug that in to your function, and you get your y-coordinate. Okay, so there it is. That's your general picture of a quadratic function and the graph of a quadratic function and how it can be obtained from your basic squaring function. Now, I haven't shown the vertically stretched function, but it's going to have this shape. It's going to look like this. So you start with the basic squaring function, you vertically stretch it, you shift it over, you shift it down, or up. Okay, you shift it in the x direction, you shift it in the y direction.